Geometry students, this is Mr. Sikora. I'm here on a nice hot sunny day in July, and as you can see, a pretty good limbs down after we had some strong storms roll through last night. And we're looking at this tree lost its limb and has lost a few other limbs in the last several months. It's a real tall tree, and it's sitting right next to a pretty busy road and some power lines that we'd rather not have go out. So possibly we're looking at cutting it down, but first we need to know how tall it is. I don't really have any way of monkeying up there and measuring how tall it is, but with just my own body and a normal measuring tape and my geometry skills, I'll be able to measure this with a little trick that I'm going to show you. Okay, I've stepped back as far as I can go and seeing the top of the tree and the base of the tree and being about level with it. What I'm going to do is I'm going to set up similar triangles. One I can measure on the ground and it will approximate the height of the tree. So in order to do that, I'm basically making a line with the tree, and I need to set up a triangle up top. So what I'm going to do is I'm going to stick out my arm and put the base of my hand at the base of the tree, and my thumb should go to the top of the tree, which is pretty close. I could probably go back a little bit further. What I'm going to do is I'm going to lay this off to the side. Keep it at the base of the tree, and now see where my thumb's at. It's past those bushes. So what I'm going to do is I can either have a buddy go over there and mark it, or I can pretty much approximate it from here. I'm just going to go on over there and set up shop at a perpendicular line to that tree. But I did my measuring. That only took about a minute, and I went 4 full measuring lengths at 16 feet, and then what I'm at right now, search that out for my last mark, and I'm at 11 feet. So 64 plus 11, we're looking at 75 feet tall for that bad boy. If I get a price estimate from the cutters, then we might actually get this guy down. But that was your trick, and I'll draw it out for you, and you'll be able to see what exactly we used. Okay, so I took the liberty of drawing this pretty crudely for everybody, save us time. And what happened here was that I set up a similar triangle ratio. From the line of my sight here, as long as my thumb was theoretically, and it was pretty close, was perpendicular to the ground, and this tree pretty close, perpendicular to the ground, I've got 2 similar angles there. Now, what else do they share? My line of sight. My line from the horizon, straight ahead, in the bottom of my thumb, to elevation, the angle of elevation, up to the top of the tree. So they share this angle. By angle-angle, or angle-angle similarity, these 2 triangles are similar. So the ratio stays the same. My thumb is directly corresponds to the height of this tree because they're in the same position in the triangles. So if I could just rotate my thumb the way I did off to the side, I just rotated it off to the side, the ratio stays the same. As long as the base of my hand was still at the base of this tree from my line of sight, the new position of my thumb, and that was way over here off on the driveway, now the distance from here, as long as it's perpendicular from this line right here that we made walking out to the tree, as long as that's perpendicular, and you have to kind of view it as it's going out in a different plane, then this distance that we can measure on the ground is the exact same, or really close, since we kind of approximated to the height of the tree. So it's something that we can measure, and we came up with 75 feet. there you go. We got an actual real world application of the stuff we're learning.